We're facing unprecedented climate change. Carbon engineering is at the leading edge of developing technology to reduce that threat.
We must do something about the rising levels of carbon dioxide in our atmosphere. We can and must transition to sustainable sources of low-carbon energy. We're doing that, but it will take time. We need more tools in the carbon climate toolbox. Here at Carbon Engineering, we are developing technologies to take carbon dioxide directly out of the atmosphere. With the appropriate design at the right scale, we can start today.
David Keith is talking about carbon engineering's technology to absorb carbon dioxide directly from the air around us. This is very different from traditional carbon capture and storage. Air capture absorbs carbon dioxide that's already been emitted. This seems to be one of the only feasible ways of trapping emissions from small mobile sources like cars, trucks, and planes. Emissions that represent 60% of the total today, emissions that are likely to increase in the future. Of course, trees do the same thing, but studies show us that planting enough trees in the numbers needed would require diverting vast amounts of agriculturally productive land. In fact, to absorb as much CO2 as an air capture facility, trees would require roughly 1,000 times more land. By contrast, air capture can be installed on land that isn't worth cultivating. It does sound difficult. Carbon dioxide only represents 1 out of every 2,500 molecules in the air. That's 300 times less concentrated than CO2 coming out of a smokestack, and smokestack technology is still not fully operational. But capturing carbon dioxide directly is feasible. That's already happening at Carbon Engineering's prototype contactor at the University of Calgary.
So this is our prototype air contactor. This is the smallest module of what will eventually be multiplied up many times to form our full-scale system. I'm standing at the inlet, so air containing CO2 enters here. And roughly speaking, we need about this kind of area to absorb the emissions being created by some car or truck somewhere else. Now with this full system, we're absorbing emissions from about 14 or 15 vehicles. And we're using a lot of the stuff inside here that we've borrowed from other industries and other uses. But in each case, we've tailored them and re-engineered them for our purposes here. Now inside this device, we've got two main things happening. We've got air flowing in this direction. Then we supply our CO2 absorbent liquid to the top so it flows down with gravity. And where they meet is right in the middle of the device that's filled with all these tightly corrugated PVC sheets.
Every single surface inside the stack is wetted with the carbon dioxide absorbing solution. Air containing CO2 flows over these surfaces, and when CO2 molecules encounter the liquid, they're converted to carbonate. The geometry of the packing material ensures that as much of the liquid as possible is exposed to the passing air. It also disturbs the flow, creating turbulence, so most of the air streaming through actually makes contact with the solution. The net result? Carbon dioxide is trapped in solution for further processing.
This material's great, but one of my jobs is to make it even better, and we're making good progress on that. Now we'd open this up for a look inside, but we're capturing CO2 with it right now. And by the time we get to the outlet here, where these fans pull the air through the contactor, over 80% of the CO2 has been removed. We're trapping over 100 kilos of CO2 here every day, and that CO2 gets absorbed into our solution and forms a type of carbonate salt. With our full-scale system, we're not just going to leave it at that.
The next step is to get back the carbon dioxide from its carbonate salt. Carbon engineering is doing that using paper industry technology already proven at large scale, but they're testing a membrane-based system that should consume much less energy. Either way, the capture solution goes back to the contactor, a stream of pure compressed carbon dioxide is generated, and any CO2 produced during the separation process is part of that stream. There's almost no new carbon dioxide released. This prototype represents a tiny segment of the full design. The internals of this 100 kilogram a day unit will do the same at large scale and can be replicated 10, 100, 1,000, even 20,000 times. At that scale, emissions from 300,000 cars could be captured every year without significantly changing the technology of the carbon engineering prototype. The prototype is building confidence that air capture can be done efficiently and cheaply. there are significant advantages to building scaled-up air capture installations.
Carbon dioxide is everywhere. This means that air capture technology can be used anywhere on the planet. This gives the system incredible flexibility. Air capture can be deployed in areas where there is an abundance of renewable energy. Additionally, it means that air capture can be size matched to the local economic and industrial needs for carbon dioxide.
Today, carbon dioxide itself is a valuable commodity, but here's a very attractive future scenario. Combine captured atmospheric carbon dioxide with hydrogen generated from water using renewable energy. Hydrogen itself can be used as fuel, but that requires a whole new transportation infrastructure. But combining it with CO2 from air capture could produce hydrocarbons like gasoline and jet fuel. We're already set up for them, and when these fuels burn, they would simply release their carbon dioxide back to the atmosphere from where it came. This would be sustainable, and the long-run cost for providing the CO2 for these fuels would be little more than $1 a gallon. Environmentalists see promise in air capture too.
It's an exciting new technology. It also is an exciting story for Calgary. As a Calgarian, as a Canadian, I'm very encouraged to see an entrepreneurial approach to reducing carbon emissions. It says that Calgary can be an incubator for not just new technologies for recovering oil sands, but also be part of the solution, part of building a lower carbon energy future.
There's a growing buzz about air capture. The Economist, NPR, and Fortune magazine have featured the work. Bill Gates is one investor in carbon engineering. Capturing carbon dioxide from the air is an important challenge. That's carbon engineering's motivation and its business.
If you like our video, then please like, comment and subscribe. And thanks for watching.